Hello students, so let us continue the discussion on motion in two dimensions. So first we are going to see projectile motion, which is like oblique 2D, oblique 2D, oblique projectile motion. So what it is? So a object, let's say there is an object. This object is being projected like this, okay, with the initial velocity u, and we can assume that this is x-axis, this is angle theta, and this is y-axis, okay, x-axis, y-axis. So what will happen to this body? So this body is going to move and finally it will land here, let us see, okay, it will finally, and at one point it will come to the maximum height, okay. So let's understand how things happen. So again we can study separately along x-axis and y-axis as I told. So let's resolve this velocity. So this velocity along this axis is ux, and the velocity along y-axis, initial velocity, this is uy. So ux is u cos theta, and uy is equal to u sin theta, right? Okay. So now when it comes to this vertical maximum height, here only this velocity is there. Along y-axis velocity is 0, and this is the velocity along x-axis. Okay, now we have to understand what happens in projectile motion. So the main key idea here is there is no acceleration along x-axis, because the only gravity is acting along downward direction, right? So downward direction there is only acceleration, which is due to gravity. So we can say, and if you take downward direction as negative, upward direction as positive, this direction positive, x-axis, this direction negative, this sign convention is up to us, right? So acceleration along x-axis, let's study x-axis motion. X-axis motion. So along x-axis there is no acceleration, we already know. So this is a uniformly, and this is a uniform motion, right? And along y-axis motion, there is a uniform acceleration minus g. We can write like this, minus g, right? This is uniformly accelerated motion, uniformly accelerated motion. So according to this two different type of motion along x-axis, y-axis, we can study separately and simultaneously, and other way we can study in the form of vectors. Both are possible, okay. So let's study and see what are the important things here, okay. So some of the important things that are, first that the total time of flight, total t is the time of flight, time of flight is capital T. Second, there is range is capital R, and third is maximum height, h max, okay. So what is maximum height? As we discussed, this is the maximum height, h max. What is the range? Range is this distance from here to here, this distance, this is called range. Range is the maximum horizontal distance traveled, because after that it will again hit the ground, right? So these are three things. And time of flight, initially you have thrown or projected time 0, it is coming here at t is equal to capital T. So these three things are important, right? Let us see the relationship between them. So let's study x-axis motion, y-axis motion separately and simultaneously, okay. So it is going like this. So we have projected it, this is the initial velocity u of projection. So with the x-axis it is making theta, right? So if we are going to study the motion of this body, let us say along x-axis we study. So if you only study along x-axis, then we have to only consider x parameters. Here this is ux, this is uy, right? U cos theta, u sin theta. When it is going to come here, we should know that it will have this same, because when it come to the same level, same height, speeds are same. Okay, so this is ux, and this is in downward direction, it is right, u sin theta, same, u cos theta. And at this point, at the maximum height, it has only this direction. This is ux. You can say this as vx, but this vx is going to be same as ux. Why? Because this velocity is not changing along x-axis, right? Because there is no acceleration along x-axis. Y-axis, here velocity will become 0. Other places velocity will be there along y-axis also. Okay, so let us first of all calculate time of flight. So we can study the y-axis motion. Let's study y-axis motion. If you study y-axis motion, let's write the formula for displacement, because y-axis is uniformly accelerated motion. So y is equal to ut plus half a t square. Okay, and these are the y-axis component. All these are y. So let us substitute here. So when it is at ground, initially and finally it is in the ground only, so vertically there is no displacement, you can put 0. So uy, this time is the time of flight, or in general you may put t, but we can see about the solutions, right? T square. So if you solve this, there will be two values of t, one is 0 and another is 2 uy by t. So of course 0 means initial time and this is the final time. So time of flight we got as 2 uy by g. This is what it is, 2u sin theta by g. Okay, this is the formula for total time of flight. And you know the time of ascent and time of descent are same. So if you want to write time of ascent will be half of this, that means uy by g, which will be u sin theta by g. And this is also the time of descent, right? So time of ascent and time of descent can also be written in terms of this uy by g. Okay, then let us see the maximum height and range. And also we should know that along x-axis the speed is not changing, right? It's constant. So if I study this range is the distance traveled along x-axis. So if we study x-axis motion, so this distance range is equal to, distance is speed into time, so ux into t, total time of flight. Now here we can substitute this value, right? So range will become ux, this is 2 uy by g. So the formula for range is 2 ux uy by g, right? And if I substitute ux uy in terms of sin theta cos theta, I can still write range as u square sin 2 theta by g, right? This is how I can write the range. Okay, then remaining is h max. Let us see h max. So to study the maximum height, we need to study the vertical motion, right? Vertical motion. So initially it is uy, at the maximum height this vy becomes 0, and this is the vertical displacement, which is h max, right? Okay, so of course the path will be like this, path may be like this. Okay, but we are just studying the vertical motion, so even if you don't draw path, that's okay. Okay, so let's write the formula along this direction. V square equal to u square plus 2x we can apply. Y-axis motion, we are studying again y-axis motion, so we can write v square equal to u square plus 2a, x means here y. Okay, so along y-axis it is everything. So final velocity is 0, initial velocity is uy square, x this is minus g, right, and y is this is h max. So from here h max comes out as uy square by 2g. Okay, so this is how we can calculate h max, and now we can substitute values here. This will be u square sine square theta by 2g, right? So this will be the h max formula. So in this way we can derive everything. Now let us see the equation of trajectory. Trajectory equation we will see. Trajectory. So it is going along this path, right? So any point you can take as x comma y, and this is origin 0 comma 0. So it has traveled x distance and y distance simultaneously. That means time 0 it is here, and at some time t it is here. So again we write, so in this direction it was ux, and in this direction it was uy. Okay, ux was u cos theta, uy is u sin theta. Okay, so if I write x along x-axis, so distance is equal to speed into time, right? So speed into time. So this will be u cos theta into time. So from here time can be calculated. Why? Because we want to eliminate time. Then only xy relationship will come. So this is x-axis motion. X-axis motion. So in x-axis motion we can write this. Similarly, now take y-axis motion. Y-axis motion. So let's write y displacement. Y is equal to ut plus half ut square. Right? Now here we are going to substitute this time. So this is u sin theta, right? Time is x by u cos theta minus half g x square by u square cos square theta. So from here, after you simplify, you will get x tan theta minus half g x square by u square cos square theta. So what is this? This is the equation of the trajectory, right? This is the equation of trajectory. Equation of trajectory. Trajectory. Which is nothing but it's a parabola. It is a parabola. It's a parabola. And when we have equation of parabola, we can calculate focus and other things. That's the mathematics part, right? That we can do. But this is what is projectile motion. In projectile motion, oblique projectile motion, this is what the concept is. Then some shortcuts, some formulas we'll see in the next class. Okay. Thank you for your attention.